Welcome to Cake Boss! Today, we're going to be making a cake, but all we have are the plans. I can help you there, pal. All we need to use is ratio and proportion. Well, first, we have to remember that the cross products property that states that in a proportion, A over B equals C over D. It also says that B and D can't be equal to 0, and therefore AD equals BC. So we see that the ratio for the model to the actual cake is 1 over 5. This means that 1 over 5 is our A over B. To find C over D, we simply have to plug in our measurements. We know that the radius for the model cake is 3 centimeters, but we don't know the real size. So we plug in 3 centimeters and end up with 1 over 5 equals 3 over x. Then we have to solve for x, which would be the real cake size. To do this, we have to cross multiply and solve for x. This ends us up with x equals 15. Now we just have to find the height of the cake. For this step, we must replace 3 centimeters with 2 centimeters in the equation, then cross multiply again. This ends us up with a 10 centimeter height. To summarize, we found that the real cake has a radius of 15 centimeters and a height of 10 centimeters. Well, I have all these triangle decorations for the cake, but I don't know which of these are the same. Well, I can help you there, pal. All we need is triangle congruence theorem. Yay! According to the angle-angle postulate, if two angles of one triangle are congruent to two angles of another triangle, the two triangles are similar. There's also side, 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 and side, angle, side that say the same thing, only using different parts of the triangle. So let's say on triangle ABC, segment AB is congruent to segment DE on triangle DEF, and that segment AC is congruent to segment DF, and finally, the angle A is congruent to angle D. This would mean that by side, angle, side, triangle similarity postulate, triangle ABC is congruent to triangle DEF. You can also do this by finding all the sides, or as stated before, 2 of the angles. Now, all that Chef Gabe has to do is find the side lengths or angle measures of his decorations. Thanks for all your help. Now, thanks to ratio and proportion, I know how big to make the cake. And when it comes to choosing the different triangle decorations, I know to use side, 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 angle, side, and angle, angle postulates to help me decide. No problem. Now you better get back to work making that cake for that party.
How are you doing that? Teach me your ways.
You want to learn earthbending? It's simple. To start you off, start by practicing how to make triangles. Make this triangle, but the side lengths have to be half in size.
How do I do that?
Tok's triangle has side lengths of 6 inches, 8 inches, and 10 inches. Eng needs to make a triangle with side lengths half the size, but angle measures the same. To do that, we need to use similar polygons. Similar polygons have corresponding angles and corresponding side lengths. Eng's triangle has to have congruent angles to Tok's triangle. To find the side lengths, you have to use the scale factor. Scale factor describes how much the figure is enlarged or reduced. Because Tok wanted Eng's triangle's side lengths to be half of his, the scale factor is going to be 1/2. If we multiply the side lengths by the scale factor, we will get the side lengths of Eng's triangle. 10 times 1/2 would be 5, 8 times 1/2 would be 4, and 6 times 1/2 would be 3. So Eng's triangle side lengths are going to be 3, 4, and 5.
I did it! I transformed the Earth into a triangle just like you. But how do I know if the two triangles are proportional?
By the triangle proportionality theorem, if one line is parallel to another line of a triangle, and that line intersects another triangle, the two triangles are proportional. Basically, what Toph is trying to teach Eng is the triangle proportionality theorem. This states that if a line of a triangle intersects the other two sides, then it divides those sides proportionally. In this example, it would mean that if the side with a length of 4 is parallel to the side with a length of 8, when the two 40-degree angles are on top of each other, then it divides the other two sides proportionally, therefore making the two triangles proportional. Let's get back to their practice to see if Eng's triangle is in fact proportional to
Hey look!
Toph's.
These two lines are parallel. And this line intersects the big triangle.
That means that the two triangles are proportional. Nice job making that triangle. Making triangles in earthbending can be very useful. Now I want you to broaden your horizons and make a square. To start, I want you to copy my square, but make the area 1/4 of mine.
Is there another theorem that I can use to help me learn this?
This is another situation that similar polygons can be used. Toph's square side lengths are 16 and 16. Toph's square has an area of 256, and Eng needs a square with an area 1/4 of Toph's, which would equal 64. Since the side lengths of a square are equal, Eng can find the square root of 64, which would give him each of the side lengths. The square root of 64 is 8, so Eng needs to make a square with the side lengths of 8.
Thanks for teaching me all about earthbending. Now I can use the triangle proportionality theorem and similar polygons to go stop the bad guys.
No problem. Now get back to your adventure.